Chapter 7 is all about roots. If I'm looking for the fourth root of something, I'm looking for something that multiplies to itself 4 times to be able to pull it out. For example, this x to the 8th is the same thing as 1, 2, 3, 4, 5, 6, 7, 8. That really comes out 4 of these and 4 of these. A single x squared is going to come out, and nothing is going to be left inside. This 256, if you factor this all the way down, you'll find that 256 is the same thing as 4 to the 4th. You could also get 2 to the 8th, but 4 to the 4th, if you pull out a 4 to the 4th, 1 4 comes out, no 4s are left inside, so this just equals 4x squared. If you have the square root of x minus 8 squared, I wouldn't factor all this out. What I would do is say, well, I know that this is x minus 8, and since I'm looking for the square root of something, I just need 2 of them. 1, 2, both of these come out as one single x minus 8. In 7.2, we're writing rational and negative exponents and using conversions. If you have y to the negative 2/3, the negative tells you the whole thing is being put into a fraction, or we're going to call that doing an inverse. So that negative puts me here. This 2 is the power, or the exponent itself, and anything in the denominator is your root. So that 3 tells you that I have a cube root of y squared. Same thing here. You just need to remember that unless there's a parentheses around the entire 5x, that 5x is 2 separate terms. This 5 does not have a negative 2/3 to it. So these 3 things have positive exponents, so that's 5. Here's the 5th root of y to the 4th, and this is z, not underneath the root, and the x is the only one underneath because it does have a negative, and that's the cube root of x squared. When you're multiplying two things with the same base, you add exponents. So it's not 1 plus 2 and 2 plus 3. You need to actually get a common denominator first. So that's 6 and 4/6, which is adding together. It's going to equal x to the 7/6. If I'm trying to add or subtract things with roots in them, I can only do it if they have the same term. So like this and this, if you just say like, well, this is x and 8x, then I really have 1 minus 8x, 1x minus 8x, which is the same thing as negative 7, and radical cube root of 7. These can't combine with each other until I get a common root. Since this happens to be the same thing as 6 times 4, if I factor, this 4 can come out, right, as a 2, and that makes this 8 radical 6. Look at that. Those cancel out, and my answer is just negative 7 cube root of 7. In simplifying radical expressions, first thing you want to do here is pull out common factor. In this case, that's 9. It makes it really easy to see that this is going to factor very nicely. This 9 can come out as a 3 because you have the square root of something, so that's 3. You can only take out square roots when you're multiplying again. This can factor into an x plus 2, which is x plus 2 squared. The square root of that is just x plus 2. You can leave it like this, or 3x plus 6. That works as well. This problem, I want to multiply everything together, because as long as I have this cube root underneath, I can actually multiply everything together. So this will be a negative. 9 times 9 is 81. This will be x to the 8th, and y minus z to the 3rd. I can take out things in multiples of 3s. This negative 1, if you think about a negative 1, that's also equal to negative 1 times negative 1 times negative 1, which is really negative 1 cubed. So the cube root of negative 1 cubed is really just negative 1. So that can come out as a negative 1. This y minus z, all of those can come out as a single one. X to the 8th, if I'm looking for groups of 3s, then I can really take 2 of them out, and I'm going to have 2 left inside, because it's like I took out an x to the 6th, and that came out as an x squared. This 81 is the same thing as 3 to the 4th, so I can actually take 3 of these out as well, and really this will be a negative 3 x squared y minus z, and the cube root of 3, because 1 is left over, x squared. Last problem in this section, the fifth root, I can just take things out in multiples of 5. 5 goes into 8 to the 9th once, so 1a can come out with a remainder of 4 inside. 2b's can come out, b to the 10th, with 2b's left inside. And on the bottom, 2c's can come out with a remainder of 3 left inside. Converting back and forth between rational and exponential notation, I want to turn any time that I see a root into a rational exponent. So a cube root really means something to a 1/3. And when you bring powers to powers, you actually multiply those powers. So 1/3 times 12 is 4. And you again multiply. So this will be x to the 8th, y to the 20th. Do the same thing, x, y. First it's to the 1/2 because that's inside the 1/3. Multiply these two together, so 1/2 times 1/3 is xy all to the 1/6, or x to the 1/6, y to the 1/6. Unlike the other problem that was x to the 1/2 times x to the 1/3, that one you had to add because that was a multiplication problem, not a power problem. This is n cubed to the 1/4 or n to the 3/4. Simple enough. And this one you wanted to write using exponential notation. So on top you're going to have x to the 3/2, because this was x to the 1/2, all over y to the 2/3, or x to the 3/2, y to the negative 2/3, because anything in a denominator has a negative exponent. Rationalizing denominators means getting any and all roots out of the denominators. You do that by multiplying the top and the bottom by whatever radical you have underneath. You don't need the 2, you're just trying to get rid of that radical. So here, radicals multiply underneath, so this is 3 radical 15. You don't distribute here, this doesn't become a 9. You're just multiplying what's underneath the radical. This will be 2 times radical 3 times radical 3 is either radical 9 or just 3. Those 3's will cancel out, and you just get radical 15 over 2. If you have a cube root, however, best thing to do is split up what's on the top and what's on the bottom first, realizing that instead of trying to just multiply by what you have underneath, I actually need to make these into cubes. So how do I make this into an x cubed and a y cubed? Well, I need to multiply by the cube root of an x and a y squared. That's what's going to give me an x cubed underneath so I could pull it out, and a y cubed underneath so I could pull it out. Got to multiply the top and bottom by the same thing. So on top I have cube root of 2xy squared over, this will be cube root of x cubed, y cubed, or just xy. If you have two separate terms, the thing to do is multiply by the same thing that you have on the bottom, except you want to subtract or change the sign. If it's subtraction, you add, and if it's adding, you subtract. So by multiplying by this, I'm going to FOIL here and say this is going to be 16 times 2 minus 4 radical 10 plus 4 radical 10 minus radical 5 times radical 5 is just 5. And this I'll distribute later. The reason I do that is because see how these guys cancel? If I multiply by the same thing, they wouldn't cancel. You would still have radicals underneath. So I'm just left with 4 radical 2 minus radical 5 over, this is 32 minus 5, which is 27, and I can also cancel these because 3 goes into this twice and this 9 times, so 2 times 4 is 8 radical 2 minus 2 radical 5 all over 9. To solve radical equations, you want to get rid of the radicals, in this case by cubing or squaring both sides. This one, cubing, will make it the easiest. Cubing something to the cube root just makes itself. 3 cubed is 27, subtract 5 from both sides, you get 22. Next one is a little bit tougher. You have to square both sides, but you don't want to get both radicals on the same side. You actually just want to do one side at a time. So when you square this one will just become 4x minus 3, but this one is actually going to FOIL out. So I'm going to write this out just so that you can see it. And when this FOILs out, 2 times 2 is 4, plus 2 radical 2x minus 5 plus 2 radical 2x minus 5, and then radical 2x minus 5 times itself is just 2x minus 5. I'm going to combine like terms, so here's my 4 and my negative 5, that gives me a negative 1. My 2x is over here, and I also have this, which is 4 radical 2x minus 5, and I still have this 4x minus 3 over here. Get everything else over, isolate the radical, and before you square or cube anything, you always want to isolate a radical. So move this 2x over, subtract this 2x, add the 1, subtract 2x, add the 1, so I get a 2x minus 2 equals 4 radical 2x minus 5. Now I want to square both sides. So this becomes 16 times 2x minus 5. This one I'm going to FOIL again. This is going to be 4x squared minus 4x minus 8x plus 4. Distribute. And start moving things over, because I now just have an x squared. And you can solve this from here by subtracting 32x and adding 80 to both sides, and then pulling out a 4. And that's nice enough where it's going to factor to x minus 7, x minus 3 equals 0, so x must equal 7, and x must equal 3. Just to be certain, I'm going to plug these back into my original equation to make sure that this does come out properly. So if I plug the 7 in, that comes out properly. Now if I plug the 3 in, that also comes out properly. So both of these answers are going to work. Complex numbers is the same term for anything that involves an I, which is an imaginary number, which we call the square root of -1, because that's just something that doesn't exist. In order to understand where these i's are used, we need to actually find out what I squared, I cubed, and I to the 4th are. So if you think about I squared, which is a square root of -1 times the square root of -1, square root of anything times itself is just -1. I squares are going to come up a lot. I cubed is the same thing, where you have square root of -1, square root of -1, times square root of -1. Those two, we know, make -1. This is square root of -1, or I. So -1 times I, negative I. I to the 4th is square root of -1 times square root of -1 times square root of -1 times square root of -1. These two make a -1. These two make a -1, and that actually makes a +1. If you go all the way to I to the 5th, you know that's the same thing as I to the 4th times I. I is just square root of -1. I to the 4th is just 1, so I to the 5th is just I. I to the 6th is I to the 4th times I squared. I to the 4th is, again, 1. I squared is -1, so you have -1. You just need to see this pattern, that you always have I, -1, negative I, 1. I, -1, negative I, 1, and so on. So using that to simplify these problems, I'm just going to FOIL. This is 18 plus 6i minus 24i minus 8i squared. I squared is the same thing as a -1, so that really becomes a +8, doesn't it? So 18 plus 6i minus 24i plus 8, combine like terms, I just have 26 minus 18i. This problem technically has a square root underneath, and you always try to rationalize denominators. So in order to do that, we're just going to do the same thing that we did before. Just treat I as a radical, multiply by a negative, by a positive. Just change that middle sign, so you get 8 plus 12i over 4 plus 6i minus 6i minus 9i squared. So 8 plus 12i, those 6 i's cancel. 4, and remember I squared is -1, so this really becomes 4 plus 9, so that's 8 plus 12i over 13. If I just give you I to the 23rd and ask you to simplify, remember up here, there's just a pattern. 1, 2, 3, 4. I to the first is square root of -1, -1, negative I, 1. I just need to divide 23 by 4, find out how many remainders are. There's a remainder of 3. Right? So this is the same thing as I cubed, which is -I.